Welcome back to the channel. This is the Earth Science Classroom. Now this video is on glacial erosion, looking at the different erosional processes that happen on a glacier or through glacial activity on a mountain or a landscape, and the main terms that are associated with erosion with ice. This is the Earth Science Classroom. Earth has a beautiful amount of water, and when it turns to ice, when it freezes, it has similar qualities in terms of the characteristics and how it erodes, transports and carries material, and this is very effective with glaciers, which is an accumulation of ice at a certain location, usually over a polar region or in a mountainous region. In this case, with an alpine or valley glacier, we're discussing that mountainous region and the erosional capabilities or characteristics of that glacier. So we're looking at ice and how ice breaks down rock. Now, the three main ways that ice can break down rock is freeze-thaw, which is frost weathering, plucking, which is also called quarrying, and abrasion. Now, these three kind of combine in one big series of erosional qualities to break down the rock, or break down this mountain and produce material and sediment that goes into the glacier. Frost weathering and freeze-thaw are related to the changes and phase changes between liquid water and solid water, which is ice, so the freezing and the melting. And this happens with change in temperature, with obviously elevation up high in the mountain. You might get some liquid water that is meteoric in origin that's going to fall on the mountain, or even as sleet or snow, melt during the day, perhaps in the sunshine, and then at nighttime refreeze. Now, this constant freezing and melting is going to slowly break down this solid rock that it sits on, and this will create cracks and joints in the rock system, and the liquid water, or even the ice to some extent, is going to fall and move into those cracks. Now, solid ice is about 9% larger volume than water, so when it does freeze and turn from liquid water to ice, you get a change in volume and it expands by 9%. That expansion is going to create a breaking of the rock, and it will cause larger joints and will create this positive feedback loop of more and more ice, more and more breaking of rock, larger joints, larger systems, until eventually you'll get to the point where this block of rock, this piece of mountain, is going to disintegrate and break down into small pieces, thus increasing surface area, thus increasing the rate or speed of weathering and freeze-thaw, and then eventually breaking down this large, massive piece of rock into small pieces of sediment that will be then taken by the glacier and moved with the ice. So this freeze-thaw is going to happen at the top of the glacier, the higher elevations, by the head or the horn of the geographical location, and part of the head wall will be initially broken down by freeze-thaw, which is shown by this kind of like gold kind of rectangle, this dashed line. And along the head wall and along the rock face and rock surface, you get all this breakdown of material through freeze-thawing. And then what you have is the process of taking this rock through different erosional processes down with the ice, downhill with gravity. So freeze-thaw is going to, or frost weathering is going to create little pits of sediment that can be taken by the glacier or glacier and moved from the rock face or the rock surface to the ice in general. And this is called plucking or quarrying, where the ice will literally pick up that loose bit of sediment that's been loosened or broken down by freeze-thawing and take the chunk of rock of different sizes up to or inside the ice and go with the flow, basically. And this plucking plus freeze-thaw action is going to break down the rock and create a lot of material inside the glacier or glacier. So our third erosional characteristic of a glacier is abrasion. Abrasion is the mechanical or physical impact of the material that's going to affect the rocky surface that it comes in contact with. The ice is going to push down all these rocks and scrape it across the surface and create these different erosional characteristics and formations on the rock that it's being scraped over. Now, the freeze-thaw, the pluck-in, and the abrasion all work together to break down the rock of the mountain and create a large amount of sediment, rocky material that is carried within the glacier or the glacier. Now, all these can dig out a basin or a bowl at the top or head of the glacier, which is also called a cirque, and can also be, once it melts, can also be what's called a lochen or a tarn, which is basically a small glacial pool that is formed in this basin that is being gouged out and dug out by the pluck-in, the abrasion, and the freeze-thaw, the frost weathering. So over time, this higher elevation kind of basin where the ice initially accumulates is going to get bigger and bigger and bigger. The depression increases because of more and more erosion and weathering, and then you'll also get a rock bar at the edge before the ice is going to slip down towards to create perhaps a Piedmont glacier and down towards the terminus at lower elevations. But the higher elevation, get this bowl-shaped, armchair-shaped depression being gouged out by the pluck-in, the abrasion, and the freeze-thaw. And once a glacier has retreated or diminished in size and mass and moved up the high elevations, you do have or left with these physical qualities or characteristics you see on the rock surface which denote a glacier was there, and the abrasion and the mass and the friction and the energy that the glacier puts upon the surface of the rock. What you see here is a bunch of striations and lines in the same direction as the flow of the glacier. And this is called the scraping and the mechanical weathering that occurs from abrasion, and you might get some of the pluck-in from the joints here, but you do get this beautiful system of rocks showing these lines of where the glacier flowed. So in conclusion, the erosional qualities of a glacier or glacier include freeze-thaw, abrasion, and pluck-in, and these three combine to create these beautiful landscapes and these beautiful geological formations up in the mountains which are very characteristic of a glacier. Now, the channel or the area in which the glacier is going to flow is a certain shape. It's generally a U shape. It's very wide and broad, but does come down to a central point lower in the elevation, and you get this nice wide U-shaped valley created by the erosional qualities of the glacier and how it's going to kind of not just dig down like a river, which is more of a V shape, where you get the erosion, weathering, and the kind of more vertical digging down of the water. With ice, you do get the same vertical erosion and weathering, but you also get the lateral digging out and pluck-in and abrasion of the side walls of the valley, creating this beautiful U shape, which is very characteristic of a glacier. And you can see the immense power of glaciers and the erosional ability of these glaciers. Thank you so much for watching the video. I hope you enjoyed it. If you like it, please subscribe and maybe hit the like button. If you like more on this content, please check out my channel, which has all these videos on earth science.